And yes. All right. So page number 2 of the MCQ paper for the measurement MCQ paper. Tell me your problem numbers, or or write in the chat window, but don't flood it. এই পেজ থেকে কার কোনো প্রবলেম আছে কিনা? Question number 1 through 14. Anyone? We'll give it 10 more seconds. Going down. Page number 3. এখান থেকে কার কোনো প্রবলেম আছে কিনা? Anyone, anything that you couldn't do, that didn't make sense, that the answer didn't check out? যারা এখনো ওয়ার্কশিট করার প্রসেসে ইন্ডালজ করতে পারো নাই, my heartfelt সমবেদনা for you, and please do start these stuffs. Have a PC, get it on. If you don't have a PC, then use your PDF and use a Adobe Reader that has option for PDF editing, so that you can give tick marks in this paper and save it in that format, because the original format will always be available on the group, so you can edit your own format. And you should have a piece of paper where you have your all the problems listed, or you should do your calculation in a different piece of paper and keep that paper for your future reference. কারণ তোমরা এখন মানে যারা অ্যাবসলিউটলি সফট কপিতে সলভ করতেছো, আর যদি হার্ড কপি প্রিন্ট করে নিয়ে থাকো, ওয়েল এন্ড গুড। আমি যদিও তোমাদেরকে সবগুলো ওয়ার্কশিট আস্তে আস্তে পাঠানো শুরু করবো, তোমাদের অ্যাড্রেস সবই নিবো, পাঠাও, পার্সেল সার্ভিস দিয়ে পাঠাবো এগুলা ওভার টাইম, বাট দ্যাটস গোনা টেক সাম টাইম। Developing the infrastructure, I'm definitely up for it, so we'll see about that. So এই পেজ নিয়েও কেউ কোনো কোশ্চেন করতেছো না, so we'll moving on. Page number 4. Any question from page number 4? Anyone? Any question from page number 4? এখানে আচ্ছা, পেজ নাম্বার 5. Kids, page number 5. পুটুং পাটুং শব্দ হচ্ছে কোথায় মেসেঞ্জারে? Page number 5. Anyone? Respond. এই টাইপের যে ইউনিট ক্যালকুলেশন গুলো করতে হয়, ফর এক্সাম্পল কোশ্চেন নাম্বার 54, the frictional force F on a sphere falling to a fluid is given by the formula F equals to 6 pi a eta v, where a is the radius of the sphere and n is a constant and relating to the fluid of v and blah blah blah. এটা ইউনিট কত হবে বের করতে বলছে। সো এই টাইপের ম্যাথস গুলো সবাই করতে পারো কিনা? এটাকে সাবজেক্ট করতে হয়, তারপর কনস্ট্যান্ট গুলো আছে, সব ভ্যারিয়েবল গুলো বসে আস্তে 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 ভাঙতে কাটাকাটি করতে করতে একটা এক্সপ্রেশন আসে। সো ক্যান ইউ ডু দিস কাইন্ড অফ ম্যাথস? It might be a bit time consuming at the beginning, but over the time you will be able to do them much more faster. But শুরুতেই don't try to do them really fast at the beginning, that way you will be having mistakes. Index mistake হতে পারে, তোমার পজিশনিং মিস্টেক হতে পারে। So go slow for the first time. Once you get it correct, get your technique correct, get your procedure correct, then you can slowly start to speed up, and that will be very good for you. But don't try to speed up a wrong process, that's devastating. Okay, no question from page number 5. Page number 6. Anyone? Page number 6. No. 1.2. Page number 7. Problem bolo. Page number 7. I'll be discussing number 4 by default, whether you ask me or not, because number 4 is a question that requires attention. I'm starting the discussion for number 4. For those of you who couldn't solve it, or if you have confusion, have a look at number 4. Read the question. A mass is dropped from rest and falls to a distance of 2.0 meter in a vacuum. An observer records the time taken for the mass to fall through the distance using a manually operated stopwatch and repeats the measurements a further 2 times. The average result of these measurement times displayed in the table below was used to determine a value for the acceleration of free fall. This was calculated to be 9.8 meter per second squared. Achha. So we have the time. Excuse me. My bad. So we have the time over here to for the same height fallen by a solid object for the within a gravitational field in a certain location. But well, for whatever reasons, we have very different values. So first measurement gave us a value of 0.6 second. Second measurement gives us 0.73. The third measurement gives us 0.64. We did average of these 3 values, and somehow after using the average value of this time record for the fall, we could calculate that the gravitational acceleration was 9.8 meter per second square. Now we do know that the gravitational acceleration is 9.8 or 9.81 meter per second square. So we can say that this result is perfect. So in terms of accuracy, this experiment was highly accurate. This data set is highly accurate, but in terms of precision, you cannot say that, because the difference between maximum and minimum is quite large. The maximum time value that this experiment provides us is 0.73 seconds. But the smallest time frame we have is 0.59 seconds. So you have about 0.14 seconds worth of difference between maximum and minimum. So we wouldn't say that this data set is precise, but somehow this data set is accurate because it gives us the exact value of G, 9.8 meter per second squared. So we are going to just try and justify what are these 4 options mean and why one of them is the correct answer compared to the other 3. So have a very good look at the answer choices. I'll be elaborating them. Answer choice A reads, the measure, question was which experiment best relates to the experiment? Which option best relates to the experiment? Ete bolse, the measurements are precise and accurate with no evidence of random errors. This is highly wrong. If there were no random error whatsoever, then all of those readings are supposed to be identical. These measurements can be said to be accurate because the average value of G was correct, but they are definitely not precise. So A is wrong. A is out of the question. B says the measurements are not accurate, but not always recorded to the degree of precision of the measuring instrument, are not according to the degree of precision of the measuring device. Sorry, go ahead. The measurements are not accurate and not always recorded to the degree of precision of the measuring device, but the calculated experimental result is accurate. Well, the question says the measurements are not accurate. Well, this is okay because the measurements individually are not accurate because each individual measurement did not show us a very single value that on its own could give us the value of 9.8 meter per second squared. You can see there's a lot of variation. So each reading was not accurate. That seems about correct. The next thing that it says, and not always recorded to the degree of precision of the measuring device, which apparently is also okay because you can see the first value was recorded to the first decimal place, where the second, third, fourth value was recorded to the second decimal place. So if you want, if you wonder that the first value is 0.6 meter per 0.6 second, why can't we simply consider it 0.60 second? There comes the idea of the capability of the device, and also the standard way to record some data. If you are recording some data in your in some cases, or if you are representing some data that was averaged out, you should always give necessary zeros to make the decimal place represented. This was apparently because the second, third, and the fourth reading of the time measurement would infer that the stopwatch that we used, or the time measurement device that we use, could measure the time up to the second decimal place. But the first value only represents first decimal place. So we can as well guess that the first value was 0.60 second. But since the student did not write that zero, so we cannot give him credit for it. This is a way of wrongly representing the data. Even if you have a zero on the very right side after the decimal point, mathematically it doesn't have any value, but in terms of accuracy and precision or for measurement quality, that is a highly important information. So the second part of the question, which says that all of these readings were not recorded to the same degree of precision of the device, that is also correct. And the third part says an experiment result is accurate. Calculated experimental result is accurate can be also said to be true, because as per the question, whenever we use the average value of these falling times, ultimately we got the acceleration due to gravity exactly 9.8 meter per second square. So in my opinion, all the different parts of information that is represented in option choice B, they are essentially correct. What if you go for C? The measurements are not always recorded to the degree of precision of the measuring device, but are accurate. Systematic errors may be present. This is wrong. If you even don't bother about the first second, the second sentence itself makes the entire option wrong, because if there were systematic errors, you would never get 9.8. You would always get a value that is different from 9.8, because systematic errors always shift your individual measurement to one side of the correct value. In this case, we can see that the total value that we did calculate ultimately ended up as 9.8. So we cannot say systematic error was present. There was some pretty large random error, because the deviation of maximum minus minimum is pretty large, but systematic error was not present. So this second sentence of option choice C by default makes it unacceptable. It is a number. I'm choosing the easiest way to discard C. However, I'll explain what the first sentence means. First sentence means for option choice C, the measurements are not always recorded to the degree of precision of the measuring device. Up till this is okay. This is a true thing. But but are accurate. So this is saying that the measurements are accurate. Once again, it is the same problem, that the measurements themselves individually are not accurate. The average value is accurate. So C is ambiguously wrong for the first sentence, but the second sentence, systematic errors may be present, that is a totally wrong information. So C bad. Student খুব confidently A এবং C কে বাদ দিতে পারে. What they become confused is between B and D, because they may read B, and you'll see the confusion in a bit. The range of results shows there were random errors made. Absolutely true information, but the calculated value is correct, so the experiment was successful. Now here comes the trouble. Experiment was successful. What do we mean by a successful experiment? Do you guys understand this part? How do
high accuracy, high precision?
No, that is something that we do not define as an experiment being successful. Experiment successful হওয়ার mathematical basisটা কি সেটা আমি তোমাদেরকে বলতেছি. Just give me a moment. Every now and then I'm blowing my nose, so okay, my bad. So let me tell you the criterion which determines a certain experiment to be accurate. I'll be doing some calculation over here. আমার আজকে প্ল্যান ছিল তোমাদের রাইট প্যাডটা দিয়ে ক্লাস নেওয়ার জন্য। রাইট প্যাডটা আমি বাইরে করতে পারিনি because I fell asleep and missed a hell lot of classes. উঠে যখন আমি মেসেঞ্জার অন করছি, I found 46 notifications in Facebook Messenger and notification included. I'm a dead man. না মোবাইল এখনো এয়ারপ্লেন মোডে আছে এন্ড থাকবে। ক্লাস নেই। মনে করো তুমি একটা সার্টেন এক্সপেরিমেন্ট করছো, যে এক্সপেরিমেন্টের মধ্যে আমাদের ভ্যারিয়েবল ছিল হচ্ছে মনে করো তিনটা, লেটস সে দিস ওয়ার এক্স, ওয়াই এন্ড জেড। দেখা যাচ্ছে সবার? এভরিওয়ান ক্যান ইউ সি?
Yes, sir.
এই এক্স ওয়াই জেড এর কোন একটা সার্টেন ভ্যারিয়েশন দিয়ে আমাদের একটা সার্টেন কম্পোজিট কোয়ান্টিটি বাই করতে হবে। এখন মনে করো কম্পোজিট কোয়ান্টিটিটাকে আমি র্যান্ডম একটা ইকুয়েশন দেখাই, লেটস সে দ্য কম্পোজিট কোয়ান্টিটি ওয়াজ let's say alpha, and we are trying to calculate alpha by x to the power 4 into y to the power 3 divided by ln z. মনে করো এই হচ্ছে সিচুয়েশন। এই ইকুয়েশন থেকে somehow আমাদেরকে we have to calculate the value of alpha from this experiment. Now my point is that using appropriate ways of how the individual uncertainty, or the thing that we call the uncertainty of the raw values, that will affect our final answer, that we can essentially calculate. What I'm trying to say, that once we have done our experiment, we know the value of these things with some plus minus. So let's say x equals to plus minus a plus something plus minus uncertainty, y equals to something plus minus uncertainty, z equals to something plus minus uncertainty. So ওইখান থেকে আমরা আলটিমেটলি হিসাব করে আমরা আলফার পার্সেন্টেজ আলফার আনসার্টেনিটি বাই করতে পারবো। Possible na? Think about this. We can very logically calculate the percentage uncertainty in alpha. So I'm going to write that down. যেটার সিম্বল হতে পারে এরকম, এটা হচ্ছে আলফার পার্সেন্টেজ আনসার্টেনিটি ভ্যালু। এটা পার্সেন্টেজ আনসার্টেনিটি না তো আমরা ফ্র্যাকশনাল আনসার্টেনিটি রাখতে পারতাম, আমি পার্সেন্টেজ আনসার্টেনিটি করতেছি just to give you a better idea. This percentage uncertainty means what? This means that whatever the value that we have calculated out, that could be errorful up to that many percentage. So I mean, a information physical significance to boli. What is the physical significance of percentage uncertainty? If you have a number, let's say that is 2.34 plus minus 0. Sorry, 0. Plus minus 5.67%. Let's say we have a number that shows like this. এরপরে তোমার দরকার মতো ইউনিট এখানে থাকতে পারে, so we might have that as a unit. But if you think for the value, it means this number is the average value that we have calculated. This number could be errorful on the positive side or on the negative side up to 5.67%. So within a range of 5.67%, our value could be anything. That's what we are trying to mean to by this information. So we are limited by this fraction because of the limitation of our experimental device. For example, every length measurement device cannot measure to all the fractions. For meter rules, the smallest fraction you can measure is 1 millimeter. For typical protractor that we use in laboratory, the smallest angle you can measure is 1 degree. So and for time measurement, we have the effect of human reaction time. So depending on the limitation of the measuring equipment or measuring system, the uncertainty pops up. এটা হচ্ছে আমাদের এররের একটা ম্যাক্সিমাম রেঞ্জ। এইটা যে ম্যাক্সিমাম রেঞ্জ, এই ইনফরমেশন বুঝছো কিনা বুঝো, that this value could be maximum 5.6% deviated from the 2.34 value. This value, so this is the maximum range. এরপর আমরা যে কাজটা করি সেটা হচ্ছে, মনে করো লেটস সে আমরা এই xyz এর ভ্যালুগুলা আমি তোমাদের অ্যাকচুয়াল what I'm about to tell you right now is an actual mathematical procedure that we adopt in paper 3, that is a lab paper, that is called percentage error, which is done in question number 2. Usually you are asked to calculate two different usually you are asked to calculate measure from the experiment, and they then calculate one specific quantity for two different setup. What I'm trying to mean is that in question number 1 of paper 3, you have to take at least 6 set of data, plot a graph, and do draw the tangent if required, if it's a curve, and go for the gradient calculation and everything. In question number 2, on the other hand, they do not ask you to take 6 set of data. You are given a setup, you are instructed to arrange a setup in some way, and you will be asked to take usually only 2 sets of data there. Now, the reason they have a smaller set of data over there, because question number 2 is the question where the examiners are going to judge you upon exactly how many decimal places did you write, exactly how much, what is your understanding towards the idea of limitation of the equipment. That is basically what question number 2 is about. All right, so let's say আমি মনে করো এই x এ let's say I'm going to do the same experiment as a question number 2 of my lab paper. So I'll not be doing xyz for multiple times. I'll be measuring xyz for one setup of the device, and then I'm going to measure x1 y1 or xyz for a second device. Let's say the first set of data gives me alpha 1, which has some value, and the second set of value gives me alpha 2, which has a slightly different value. Logic should tell us that alpha and alpha 2 are supposed to be equal. So in that case, because alpha and alpha 2 are totally unknown to us, we go ahead to calculate the percentage difference between them. This is an important term. I didn't teach you in the theoretical part, so have your eyes peeled. Percentage difference. Percentage difference means how much these two values have deviated from each other with respect to each other. এটা করার সিস্টেমটা হচ্ছে ডেল্টা আলফা ডিভাইডেড বাই এভারেজ আলফা। খুব ভালো করে খেয়াল করো কি বলতেছি। You'll have some numbers over here. You got these two individual values without drawing any curve or graph. You had the values obtained from your experiment. You find out one set of value, and then you repeat the experiment for a different setup. Then you got a different value. Percentage difference will be calculated by this. On the numerator side, we'll have the difference of these two numbers. Difference means big minus small. So there is no reason this can be negative. On the bottom side, you'll have average of those two numbers, which means alpha 1 plus alpha 2 divided by 2. And then you do into 100%. This gives you a measurement, an exact measurement that exactly how much is the error between the values that you have already obtained. This is called percentage difference. Percentage difference is a representation for how much deviation did your values actually have. By all means, for any experiment to be determined as a successful or to be declared as a successful experiment, for any experiment, percentage difference should always be smaller compared to percentage uncertainty. Try to understand, percentage uncertainty is the maximum amount of error we could possibly do because of the limitation of the equipments. By doing the repeated error and by using our brain, we should achieve a way so that our percentage difference is smaller than the percentage uncertainty. We should be able to get a value that is within the limit of percentage uncertainty. If for a certain experiment, the percentage difference is smaller than percentage uncertainty, then we can say, yes, we could do our experiment within the limitation that we have had, so we can declare that experiment to be successful. If our percentage difference of an experimental output is bigger than the percentage uncertainty, this would mean that apart from the equipment error, that equipment limitation that we have had, which introduced a lot of systematic errors, we ourselves also introduced some personal error. That's why the final answer had a percentage difference that is bigger than the percentage uncertainty. If that is the case in any scenario, we will declare that experiment to be unsuccessful. This is the actual criterion how we determine whether an experiment is successful or not. এই পর্যন্ত বুঝা গেছে কিনা up till now?
Yes, sir.
Any question? If you have any question, please ask up till now, because there is a second part, there is a bit more part to this discussion, which I'll tell you, but I need to make sure that you made sense of this whole part. Anyone problem? Respond, please, everyone. Yes sir, no sir, or write the problem, whatever works for you. Ifat bolo, you're about to say something, but I cannot hear you.
Sir, why does the percentage difference, if it's more than uncertainty, why does it mean we introduce some error?
It means that percentage uncertainty, whenever you do the percentage uncertainty, this is the maximum amount of error that we could have within the measurement value, due to the limitation of the equipment. That we cannot measure a length more precise than, let's say, 1 millimeter. We cannot measure a time, let's say, more precise than 0.3 seconds. Those are the limitations. Due to those limitations altogether combined, that's what we go for the combined percentage of alpha, which is the procedure that we've learned. We come to this number, which means maximum error that due to our equipment could be this much. By doing trial and error or repeating the experiment, what is it that we try to do? We try to compensate for positive and negative errors for multiple readings. So the statistical approach goes for trial and error is that if you take 6 readings out of an experiment, you can hope, or you should be careful to make it happen. You could, I could put it either way, so that 3 of the readings might be somewhat bigger than what they're supposed to be, and 3 of the readings might be somewhat smaller than what they're supposed to be. That is the whole idea of a base fit straight line. Ever heard of this term, base fit straight line?
Yes.
Yeah. So you have some dots on your graph paper where you know that you are supposed to get a straight line, but they apparently are not on a perfect straight line. So you draw a line through them so that your drawn straight line would represent the midway level of the distribution of those points. A base fit line does not have to go through any of the plotted points, but it has to represent the graphical average of all of those points considered altogether. So that's the whole idea of a base. Yes,
স্যার একটা দিয়ে যদি না যায় তাহলে কি মানে
তাহলে কোনো সমস্যা নাই লজিক্যালি, বাট একটা দিয়ে সবসময় যাওয়ানো যায়। কেমনে যাওয়ানো যায় সেটা আমি তোমাদের ল্যাব ক্লাস করানোর সময় দেখাবো, ডোন্ট ওয়ারি।
ওকে স্যার,
ঠিক আছে, since we are doing some online classes, I might as well do some video and upload it as lab class instruction, because that might be helpful. So that comes later. So what I'm trying to tell you is that using the equipment, there is a possibility of a maximum error of plus minus 5.67%. We do trial and error so that we can get rid of the random error that could get involved in the experiment. Now, if our actual error, which is the percentage difference of these two values, because here I'm only talking about two values, if there are more than two values, then what should happen? সেটা আমি একটু পরে বলতেছি। If the percentage difference is more than our percentage uncertainty, it would essentially mean that we introduced more error to the setup. So along with the systematic error that we can have from the systematic error, along with the uncertainty based error that we have in our reading, we also incorporated some additional error from ourself, which pushed the entire value outside the possible acceptable region of the equipment limitation. So what I'm trying to mean is that the error that might get involved in your calculation due to the equipment limitation is something that you cannot solve on your own. You don't have a precision equipment in your lab. You cannot measure let's say your lab does not have vernier calipers, or your lab does not have a screw gauge. So you cannot measure length to a very high precision value. That is a shortcoming that you cannot do. But you should be able to do the experiment within the appropriate precision value of the meter rule, because you have access to that equipment. Do I make sense?
yes
Yes,
sir.
sir.
ডিভাইসের জন্য যতটুকু আনসার্টেনিটি মানে the amount of uncertainty that will be incorporated because of the limitation of the device, that is acceptable. But you as a human being should not incorporate more error. You should be responsible to make that error amount become smaller. This is the criterion to determine the success of an experiment. So এটা হচ্ছে একটা part. So this is why a successful experiment should have this logic done. If this logic is reversed, then we say that experiment is not successful. Now, if there are multiple values, I just showed you here for the example of 2 data, because that is the most common case for your question number 2 of your paper 3 lab paper. If you have more than 2 data, for example, let's say if you have alpha 1, alpha 2, alpha 3, or let's say if you had alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, alpha 6, you had individually calculated six of these alphas, where you should have gone for a graph drawing where you have that many data. But let's say you chose not to draw a graph for whatever reason. The process is that whenever you do a percentage difference of a group of data, this should represent what did I write?
Maximum minus minimum.
Maximum minus minimum. If you're working with a group of data more than 2, then delta alpha, to calculate the percent difference, the numerator should represent the maximum minus minimum of those two value, and the denominator should represent the average of all of those values. Average should not be done by only 2 of those. If you have 6 values, then the delta alpha should be the difference of the biggest minus the smallest. Whereas on the denominator side, you have to write alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha 5 plus alpha 6 divided by 6. That's how we go for it. Can I pass this? Could I pass this information across? Step ta বুঝা যাচ্ছে কিনা?
Yes, sir.
Yes, sir.
This is for another step. Another third variation is there. Third variation হচ্ছে এরকম to calculate percentage difference is that if we are ever trying to calculate a percentage difference for a quantity that we by default know from earlier. If you wonder what does that even mean? For example, by repeated experiments, a school teacher knows over years of experiment, a school teacher knows what is the average gravitational acceleration at their school location is. Let's say he has conducted experiments himself and he has conducted experiments by his students and he took reliable results out of them and he has, let's say, 1500 of this data, all of which combined up to give him a value of gravitational acceleration of the location, which he or she, the teacher, has calculated up to 5 decimal places and kept it at his record. Now he or she knows exactly what is the value of gravitational acceleration from a statistical output, which you can pretty much consider to be accurate because the sample size is pretty large. So we are talking about a big number of repetition. This is the kind of a value that we can define to be true value. If the true value of a certain quantity is pre-known, known to you before the experiment, and then you do the experiment once again, in those cases, percentage uncertainty, percentage difference is calculated by this equation. Percentage difference equals to nu minus true divided by true into 100%. You can see that I given a modulus on the top. Do you see that?
Yes, sir.
Nu minus true dia modulus this. Modulus this মানে কি? What does it mean? It means that, what does it mean? This modulus means that you do not have a minus sign on top of it. So you're going to always subtract big minus small. Another mathematical way to represent this modulus thing is this expression. You might as well come across this expression at some point of your working. H inota. Have you ever seen this symbol? This one, a single curve.
Yes, sir.
You might have seen this one. Have you ever seen this one?
Yes,
Yeah.
sir.
What does this mean?
Approximate.
Approximate. Beautiful. And this one, this single symbol represents difference. So eta mathematical meaning exactly same. Big minus small. All right.
In new minus.
New. I don't know the exact name of this. It at least is true value. True value. True value means if you know the aimed value that you're trying to measure out of an experiment from earlier experiments. If the value of a certain quantity is already known to us, then we are redoing the experiment for checking the quality of the experiment or whatever reason. Then percentage difference is calculated with respect to the true value. So we are trying to find out in terms of percentage, how much did your calculated value deviate away from the actual value. For example, let's say the value of gravitational acceleration in some school location is supposed to be, let's say, 9.81345. Let's say that's the statistical data that the teacher holds to themselves. Now, some student goes ahead and do the experiment. They get 9.5623. Then the teacher can find out the difference on the numerator side. But on the denominator side, they should put their known data, which is a true value, into 100% to find out how much was the percentage difference. Once again, that percentage difference should be compared with the percentage uncertainty of the experiment. And if the percentage difference is smaller than the percentage uncertainty, only then we can call the experiment successful. Any questions so far?
No, sir.
No, sir.
Achha. Additionally, I was talking about question number 2 in your of paper 3 or the lab question in this for this discussion. In many cases or in most cases of your lab experiments, we do not know the true value. So usually we always go for this calculation. I mean, the difference of the two values divided by the average of the two values. Average we usually go for this equation, and you are not essentially made to calculate the entire uncertainty of the whole experiment. So this is something that is not, you are not made to calculate for question number 2. You are only made to calculate the percentage difference. So what the CA people have done, they have been generous, in my opinion, in the sense that the CA people have defined that we are gonna define 2 specific boundaries, whether the experiment was successful or not, or the proposed theory was correct or not. That range is that for mechanical experiments like spring, bob, oscillation, blah blah blah, for mechanical experiments the acceptable percentage difference is considered to be 15%, and for elliptical experiments the acceptable percentage difference is considered to be prescribed to be by CIE 20%. So that is the predefined value that the CIE prescribed. So we teach the values kids in that way. And whenever you have already done your experiment in your paper 3, let's say, your percentage difference might as well fall outside the acceptable boundary. You will not be judged upon, you will not be marked upon how much is your percentage difference. You will be judged upon how do you validate that, you validate your calculation. For example, doing the same applying for the same exam on the same session on the same experiment hall, I'm doing the question number 2 and you're doing question number 2. Let's say my percentage uncertainty came 23%, percentage difference came 23%, your percentage difference became 13%. Let's say it's a mechanical experiment. Now the limit as per CIE for the acceptability or saying that this is a good experiment or this is a valid relationship, for CIE, for mechanical experiment the acceptable range is 15%. So you are going to write, because the percentage difference calculated is less than 15% for this experiment, the stated relationship is valid and you'll be getting full marks for that. Because my percentage difference was calculated to be 23%, I'm going to write, because the percentage difference was calculated is more than 15%, stated relationship is not valid. Both of us are going to get full marks. Do I make sense?
তাহলে আমাদের মানে এই বিষয়ে কোনো মার্কিং হবে না।
You will not be judged upon how much is your percentage difference. You will be judged upon how do you validate your statement. What do you comment based upon what you have got? বলুন, কথাটা কি বুঝা যাচ্ছে?
জি স্যার।
Yes, sir.
CIE এই কাজটা করছে এই জন্য, what I personally believe, I didn't actually ever come across this thing that I'm about to say and to tell you right now. What I believe is that different parts of the globe, even in different lab scenarios, you cannot expect the equipment to have the exact same capability that they would expect for a standard lab procedure. Different lab can have different type of equipments. For example, some labs might have 50% of the equipment which are new and functional, which are old and functional, and they might have bought 50% of the equipment absolutely fresh from the market the night before the lab experiment. So there might be some difference of the experiment data. This thing can go even further if you consider your chemistry experiments. One reagent that is made at the beginning of the day would not hold the same concentration or purity level as the day goes by, because people would be continuously taking a reagent out of it, and there is always possibility of contamination. Do I make sense?
Yes, sir.
So this is why CIE made a smart move, that they did not want to judge the students based upon exactly how much percentage difference did you get. We are cool with it, but can you validate your answer? I mean, at least can you take the decision whether it is acceptable or not? That's what they went for. So they gave you a fixed value of percentage difference range for the paper 3 paper. So all in all, is the idea of successful, an experiment being successful or not, are we okay with this idea? That could we learn what is the variable to judge for that? Any questions so far? আচ্ছা, question হলে হাত উঠাবা। আমি any question so far বলে আমি time waste করতেছি না. If you have any question, please raise your hands. I'll respond. So have a look at question number D once again. Answer choice D once again. It reads, the range of results show that there were random errors made, correct, but the calculated value is correct. এইটুকু পর্যন্ত ঠিক আছে, it's correct till far. So the experiment was successful. Now this third part is ambiguous. You cannot say whether this experiment was successful or not, because you do not know exactly what was the percentage uncertainty of this calculation. You cannot declare a certain experiment to be successful without doing those 2 calculations. You have to know the exact value of your percentage uncertainty, you have to know the exact value of your percentage difference. Once you know these two values, only and only then can you go for deciding whether the experiment was successful or not. So in my opinion, this question does not essentially have enough data to check whether this experiment was successful or not. The experiment might have been successful, it might have been not successful. So D number is an ambiguous choice. If you compare B and D, you'd see that B is a more reliable, confident answer. Read through B one more time. Read through B one more time. You'd see that none of these parts are ambiguous. They pretty much make sense and they are correct. Whereas for D, the first two parts are correct, but in the third part, they have brought this idea of successful, which in my opinion is not possible to derive from this question. So that's why the ultimate correct answer for this question is B. Does it make sense?
Yes, sir.
Anyone else? Do some response, please. অনেক ঝড় বৃষ্টি হইতেছে। Okay, someone wrote no sir. Mahiyat. এটা কি আগে লিখছিলা? আচ্ছা, sorry. Okay. That's enough time to respond. Question number 5 নিয়ে আমি একটা ছোট জিনিস বলবো, তারপর আমি এটা মুভ আউট করে চলে যাব। Have a look at question number 5. What does it say? A student carries out a series of a series of determinations of the acceleration of free fall g. The table shows the results. What can be said about this experiment? Well, you can see that the values themselves are pretty closely clustered. The highest value of g that this student calculated was, I think, 4.93, and the smallest value that this kid calculated was 4.88. So that is 0.05 for about 4.9. So I'd say the results are quite precise. I mean, they're not really scattered in random locations. The values are really close to each other. But you should always know that if you do the average of these numbers, are you ever gonna come up with 9.8?
Yes, sir.
No, you're not gonna come up with 9.8, which means these results are not accurate. Values are precise but not accurate. Now, that is pretty simple to determine from the observation. My point is, what is the mistake that the student in this experiment possibly do to get this kind of values? What was the mistake that the student actually did in this calculation? To make you sense out of this question, I'll pull up one more reference material, which might give you a bit more better insight. এখানে কি আছে? Yes, this one. This experiment from paper 2, which we are also going to discuss when we will go for paper 2 after finishing paper 1, is that this is a very simple experiment to measure the acceleration due to gravity using a falling object. So what we are doing over here we have an electromagnet which is holding a steel ball, or so not steel ball, a soft iron ball, soft magnetic material, by the help of a circuit. So initially the circuit would be open. We have light beams over here. There are sensors. These are called light gates. The idea of the light gates is that this ball is going to start falling through. The moment this light path would be interrupted and this sensor would not receive that light, it would start a timer over here. Whenever this light is obstructed, this timer will be started. The ball is going to fall through and light will be reestablished, but the timer will not stop because we have two light gates over here. This is responsible to stop the timer. The ball is going to fall through this whole height, and after some time it's going to fall through this gap, and then it's going to block the light of this sensor. This sensor is going to stop the timer. So because we have light and electronic sensors, this is a much better and much what can I say, much less errorful method to calculate, to measure the time of a certain experiment. This works really well, in my opinion. So that is the case, and Hello? Hello?
Yes, sir.
Hold on, কথা কি শোনা যাচ্ছে?
Yes, sir.
So that is the case. So this scale is going to measure the height, and for different height, this scale is going to measure the time period. So time period, not time to fall to that height. And eventually they have come up with this graph, which is an h versus t square graph. Looks pretty good, right? H unit key. What is the unit of h?
Meter.
Meter. What is the unit of t squared?
S. Second squared.
Second squared. Acha, Polaman, before I just move on, I just want to know one thing. How many of you do not have access to a functional microphone through which you could ask me questions? I mean, how many of you believe that for the entire upcoming future, as long as the online classes go on, you're going to be always writing your questions in the group chat? You'll never use your voice. How many of you do not have access to a functional microphone? Please respond here. I have a reason to ask you this. Please do buy a functional microphone. It is important that you participate in our classes. Please do. Now, if you wonder, the functional microphones are very costly and everything. Trust me, they are not. I got rid of my Corsair HS50 microphone. What? Wow. My monitor is developing dead pixels. I just opened up this PDF and I have a lot of blue dots over here and a lot of blue dots over here. Those are dead pixels, right?
Looks like them.
And you are not even able to see that because it is a localized hardware problem. Duro. Okay, I have to get rid of this monitor. This monitor has served me for a very long time, nearly 10 years. হই পোলাপান তোমরা এখন এত বড় বড় গোলাতে ডেড পিক্সেল তোমার ডেড পিক্সেল তোমার পিক্সেলের সাইজ শিখাও আমাকে অ্যানোটেশন বন্ধ করার জিনিস কই অ্যানোটেশন বন্ধ করছি আমি আচ্ছা কি দেখাইতেছিলাম যেন কিসের জন্য জানি আমি এখানে ডিস্ট্রাক্টেড হইলাম আচ্ছা আমি তোমাদেরকে একটা জিনিস দেখাবো দেখাইতেছি একটা জিনিস দেখাই I'm going to get back to the lecture, just trying to help you kids out. I bought my Corsair HS50, which was a nearly close to 4,000 taka microphone headphone, which is a very good headphone and a good microphone as well because I exclusively record the microphone. But soon I found out through Sohail sir that these microphones work pretty well. So I then obtained through Sohail sir's help this microphone, this product. Not this one. Where is the beautiful view of this product? This product. It has an amp, which I don't need. This is a 3.5 millimeter jack input, and this is the microphone. So there's a clip over here, and currently I'm talking through this microphone, and I am actually moving my head quite a bit. But do you even sense the variation of volume?
No, sir.
This microphone is super, and and they are only 700 taka each. I'm saying only because in my perspective, it is much too cheaper compared to a 4,000 taka my headphone. Do you understand?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
so,
sir.
so they have this kind of stuffs as well. So you can use these things for remote controls or some other stuffs. I mean, there are many different options. I mean, I bought this one from a shop that is recommended by Sohail sir. I'm asking you this because for those of you who do not have access to a functional microphone, or you believe firmly my voice is going to kill all the people like Medusa did with their eyes. No, not gonna happen. You can speak up. It's okay. কিছু বুঝলা?
জি স্যার।
আচ্ছা এই মাশরুর আর ইফাত ছাড়া আর কেউ অন্য কিছু বুঝলা?
Yes, sir. বুঝেছি।
Please do preferably try to have a wish that you're eventually going to participate in the class with your voice channel. I seriously appreciate this. There's a reason for this. I for one cannot see you kids right now. Whenever physical classes happen, I can look at the kids' face, and I know for a fact, at least from my experience, that are they in the class or not? Did they understand the idea or not? I could ask them questions. If they are not concentrating, I could ask them to concentrate and whatnot. But currently I cannot. So it's important that you participate from your own end. And I really appreciate this, honestly. So here the unit of h height is meter. Here the unit of t square is secant square. If you take the gradient of this graph, just by looking at the two variables, what would be the unit of the gradient quantity of this graph? Meter per secant square. Because gradient is given by what? Del y by del x, right? Here the del y means delta h, which has a unit of meter. Del x would mean t squared, which is a unit of secant square. So del y by dx would give you del h divided by delta t squared, which would have a unit of meter per secant square. Do you agree?
Yes, sir.
You should. So
Yes,
yeah.
sir.
So this is supposed to be meter per secant squared. So that might immediately tell you, find meter per secant square is the unit of acceleration. So the gradient of this graph is acceleration. Shouldn't that does that sound good? This sounds valid, right? That the gradient of this graph is meter per secant square, or that is pretty much the acceleration due to gravity. Now, this student did exactly that error and calculated all of their values like these numbers. So what is the problem over here? Think about it. What is the actual gravitational acceleration value? 9.8 or 9.81. What fraction is 4.9 compared to 9.8?
Half.
Half,
Half.
exactly. 4.9 is half of 9.8. So essentially there is a factor of 2 error. Somewhere in the calculation there is a factor of 2. Let me show you what is that factor of 2 error. Have a look. If you consider the very default equation, s equals to ut plus half at square. Remember this equation? The third equation of motion that I usually teach the kids. If you write this expression for the vertical case where the ball was dropped from rest, I can write h equals to 0 into t plus half gt square. 0 into t বাদ চলে গেল, so ultimately আমি থাকলো হচ্ছে h equals to half gt square. That's what I have left. Now have a look. Whenever you are going to plot a value of h versus t squared, you are going to plot this graph. H is becoming your y-axis variable. This entire t squared, that is becoming your x square variable, x-axis variable, because you are plotting h versus t squared. So the h is the individual y-axis variable, t square altogether, not t only, t square together is the y-axis variable. So the part that you are left with is essentially what represents the gradient, because our straight line is supposed to be y equals to mx. A gradient ta koto? Is it g or is it something else than g?
Half g.
It is half g. So the gradient of h versus t square graph does not give you the g altogether. The gradient of the graph, which can be calculated by del h by delta t squared, that gives you half g. So to calculate g, what is it that you have to do? You have to essentially multiply that gradient by 2. Take a look at this expression. It's because the formula had a built-in half over here. The unit might apparently derail you, or it might confuse you, or it might make you mistakes, but you should know from your knowledge that there is a half in our equation, so that half should be somehow important at some place in our equation, and this is the where it is becoming important. The gravitational acceleration can be calculated by doubling the value of gradient. That's the error that the student did. Do I make sense?
Yes, sir.
ঠিক আছে? So এই টাইপের এররগুলো স্টুডেন্টদের জন্য অনেক কমনলি হয়, so you have to be careful to understand what is the source of this kind of error. So getting back to the MCQ question one more time. So a student carries out a series of determinations of the acceleration of free fall g. The table shows the results. What can be said about this experiment? What is the correct answer? What do you think is the correct answer?
D.
It is not accurate, but it's precise. It is the correct response. Yes. আচ্ছা, নাম্বার 6 এর গ্রাফ আমরা থিওরিটিক্যাল ক্লাস আলাপ করছিলাম, সো আমি এটা নিয়ে সময় দিচ্ছি না. You should know as very well know what this means. Page number 8. Any question from page number 8? যারা ওয়ার্কশিট করো নাই তারা কোন রকম নাম্বার এখন সার্চ করতে পারতেছ না. ইউ আর ফিলিং লাইক যে আমি তো করিই নাই, আমি কি বলবো, হা হা হা. ইয়েস, ডেফিনেটলি দুই টাইপের পাবলিকের ভুল হয় না, আমি হয়তো আগেও বলছি. There are two type of people who don't do mistakes. Godly people, because they know everything, they don't do mistakes. And then the lazy people, because they don't do anything, they don't do any mistakes. So if you are not asking me any questions, if you are not giving me any trouble numbers, confusion numbers, this could mean you are either of these. Now, I would presume that you don't belong to the first group because you just got enrolled in AS course. So what are you? Did you get my point of the whole two type of people thing?
Yes, sir.
So please, if you are not asking me questions, it only proves that you didn't do your homework. Any question from page number 8? It's a 21 page paper, so we might as well gear up. I'm taking enough time in places where I have to take time, but for places where you do not give me troubles, I'll not waste my time in much. So, or your time much. I shouldn't waste anyone's time much. So question number 8, anything to ask from question page number 8? Page number 8, anyone? No. This one is a very good question to discuss. Any problem for Sokyo? Jara attempt course at least? Jara select course 16. Page number 9, question number 16.
This is very problematic.
I'm going to discuss this MCQ anyway because I personally feel like that this is a MCQ worthy of discussion. So I'll take care of it. Let's have a good look at this expression. Variables x and y are related by the equation y equals to p minus qx. Very good look at the equation. Very good look at the equation. Look at this equation. Y equals to p minus qx, where p and q are constants. Values of x and y are measured in experimentally. The results they contain a systematic error. Very important information. The results contain a systematic error. Which graph best represent these results? First of all, what I need you to understand, this is not going to be a curve. This is basically y equals to mx plus c. If you wonder, koi y equals to mx plus c, y equals to mx plus c, y equals to minus qx plus p.
With
Y
the
equals to mx plus c. So this should be a straight line that does not pass through the origin. Curves are not acceptable. তার মানে এই দুটো প্রথমেই বাদ। Second thing, the gradient is negative. Both of these lines have negative gradient. Well and good. Third thing, it says there should be a systematic error, which means we should not get the value that we expected to value. We should get something more or less. Have a look. Whenever এটা যেন কি ছিল p ছিল না এটা? আচ্ছা, whenever x is 0, let's say because we have the intercept point on this position different. I mean, if you have a look at these two graphs, this is the point where they are different. This is the location where x value is 0. So if we place x value 0 over here, what do you get? Whenever x equals to 0, y is supposed to be p. That would be correct for a good experiment, for a perfect experiment, or for a non-systematic error experiment. But the question already specifies the result contain a systematic error, which would mean that whenever x equals to 0, theory tells us the y value should be p, but experiment should not give us p. Experiment should give us either more or less than p. Check this out. Experiment should give us something more or less than p because there is a systematic error. So altogether, for x equals to 0 position, you should not have this one. This one should be your y equals to px for the systematic error graph. A is your correct response. Any question?
Yes, sir.
স্যার
বলো।
এতে তো সব পয়েন্টস একদম মানে স্ট্রেইটই এসেছে, মানে বেস্ট, এটা কি বেস্ট ফিট লাইন না?
Well, if you have this kind of a line, we will definitely call it a best fit line. But honestly speaking, if in your lab experiment you ever plot a graph like this kind of plotting, examiners are gonna penalize you heavily, because this one proves that you did not do the experiment. You manipulated all the data. If you are a human being working with man-made, humane, earthly available equipment, your values cannot be this good. Probability does not allow that. You'd always have some deviation. Your deviation might be small, but you cannot have values like this. You cannot have values like this. These values represent that the experiment was perfect for all of its reading, each of its reading. যেটা সম্ভব না, statistically, probabilistically এটা possible না. So you should always have some deviation. in my lab courses, essentially I teach the kids data manipulation close to the end of the course. But if anyone asks me, I always deny it. I might as well upload this lecture in the YouTube. So there you go. But my point is that, I mean, data manipulation is a good thing, provided that you don't leave trace of data manipulation. This is a vivid visualization that the student did data manipulation and did not know that they are supposed to make some add some variation. Yes, Masrur bolo.
স্যার এখন তো এখানে তো বলেছে যে the results contain a systematic error, হ্যাঁ?
Yes.
এখন যদি এখানে systematic error আর random error থাকতো তাহলে কি হতো?
তাহলে এখানে কারেক্ট আনসার নাই।
স্যার গ্রাফটা কি রকম?
সেটা হচ্ছে যে এই মানে এরকম হতো, the straight line would not pass through P point when x equals to 0, and the plotted points would be somewhat deviated from the best fit line. Got it?
Okay. Yes.
That this spread out effect represents random error, and this
is systematic.
This intercept represents systematic error.
আচ্ছা, ওকে।
ফোনটা তোমার কাছে নিয়ে বসো, ধরে বলো যে স্যার ক্লাস নিচ্ছেন, রাতে 10:30 9:30 পরে কল করতে। My bad. Anyone, any question about this, or are we clear about this one?
স্যার
Yes.
তো মানে প্র্যাকটিক্যালি যদি আমরা কখনো করি তাহলে ভুল আসবে, বাট মানে ম্যানিপুলেট করলে তখন হচ্ছে ঠিক আসবে, মানে একদম স্ট্রেট আসবে।
হ্যাঁ, এক্স্যাক্টলি।
স্যার তাহলে এটা তো ভুলই হওয়ার কথা।
Yeah, now A is the acceptable answer because the questions already tells us that the results contain a systematic error. So you cannot choose this one because this one is not representing a systematic error. When x equals to 0, if you place x equals to 0, your y value is supposed to be p. That is perfectly shown over here, which means this graph, this setup of equipment do not have a systematic error. If you are supposed to have a systematic error, then you should not get the exact value that you are supposed to get. All of your values should be deviating in one side. For example, in this case, the line might as well should be located here. The line should have been located something like this. A line like this would have been a good line. But because of systematic error, all the values dropped down by a little value. All of them dropped them by equally. Hence, the graph is not giving you the exact intercept of p when x equals to 0. You are getting something else than p, representing a systematic error. Or in other words, I can say that this value without systematic error should have been located here. This value without systematic error should have been located here. This value without systematic error should have been located here. All of these values had a somewhat negative depression compared to the actual value that was aimed to be measured. So all the values shifted to one side. The whole idea of systematic error. Beautiful. Shomik, Pulaman, whenever the public chat is on, write your questions in the public chat. Okay, Shomik asked me a question. Is the graph B has random error? Yes, the graph B has random error, but no systematic error. That's how we can describe graph B. Bucho? Okay. I'm moving on from this question. Uncertainty calculation. Page number 10, kono question? Anywhere? You might as well ask for number 10. Number 10 could or as well number 4. Number 4 and 10 are equal. Number 4 এর আনসার আসে হচ্ছে 0.36. Number 4টা করো সবাই, যারা করো নাই number 4টা এখন করো everyone. This question I want you to attempt it right now. একটু সময় লাগবে, but do this right now. Number 4, give it a try. 1.3 এর নাম্বার 4 এর কারেক্ট আনসার কি?
স্যার আনসার ডি আসে না?
দেখি বাবা, এটা কত নাম্বার ছিল? 1.3 এর
নাম্বার 4
নাম্বার 4। 1.3 নাম্বার 4 আনসার হচ্ছে সি।
সি।
সি হবে। সি কেন হবে সেটা বলতেছি। Take a good look. These values that we have measured in this experiment, to what SF these original numbers were measured? What is the SF of these numbers? 2.50, how many SF?
3SF.
40.0, how many SF?
40.0 3SF.
3SF. So the final answer should also be 3SF, 16.0, not 16.00. And this thing should be written in the same decimal place as the original number. That's why D is not the correct response, because D is representing a more accurate result compared to what we should have got. From 2 3SF measured values, you cannot get a calculated answer that is correct up to 4SF. That implication is wrong. Do I get my point across?
Yes, sir.
So you are going to get 0.36 and something followed by that one, but you have to round it up to so that the main calculated number is up to 3SF, and the uncertainty has matching decimal place with this value. So 16.0 plus minus 0.4 is your correct response. Do we all agree on this one?
স্যার
Hello.
স্যার আমি মানে 0.1 root 0.01 to 0.1 হয় না, প্লাস মাইনাস 0.1। আমি যদি হচ্ছে 40 প্লাস root 0.01 দেই, তারপর ডিভাইডেড বাই 2.5 প্লাস root দেখে গেছি স্যার।
Hold up. We are
I
trying
need
to
to-
hold up. এখানে root over আসবে না তো। We are trying to calculate the average speed of the car. So it is a basic equation of distance over time. You're going to divide 2.50 divided by 40. Sorry, you're going to divide 40 divided by 2.5 to get the speed value. And then you have to go for the fractional uncertainty thing to combine up the uncertainties of these two quantities, and eventually you have to calculate the absolute uncertainty of the speed. That's a lot of calculation for
প্লাস
1 mark.
মাইনাসের জন্য যদি রুট ওভার ভ্যালুটা দেই তাহলে
Root কেন আনতেছো এখানে? I mean, why do you
মানে এই 0.1 এর তো হচ্ছে হোল স্কয়ার করে ওটাকে রুট যদি করি,
why are you talking about squaring this quantity?
বুঝিনি।
Speed equals to distance over time. In this equation, do we have any square or root over?
No.
So you'll get the value from this thing that is supposed to be 16.0, and then delta v by v should be equals to delta d by d plus delta t by t. There is no root over or square here as well. Therefore, the absolute uncertainty of delta v should be equals to this whole thing. You calculate this, multiply by the v value, and then you get the and from there you get the absolute uncertainty. There's no question of rooting it or squaring it, because the equation doesn't have any of those operations.
ইকুয়েশনের জন্য না, মানে ভ্যালুটার জন্য প্লাস মাইনাস আছে না, মানে প্লাস মাইনাস 0.1 এমন করে।
Sadia, I am not getting your question. আবার বলো।
এখানে মানে যে একটু এরর থাকতে পারে না 0.1 এর প্লাস মাইনাস, ওইটাও যদি হচ্ছে মানে
কোথায়?
তো কোয়েশ্চেনে
Distance measurement এ?
হ্যাঁ
This is d and this is delta d.
মানে একদম পারফেক্টলি তো 40 মিটার হবে না।
And that is exactly why we are taking this fractional calculation. That is exactly why we are doing this fractional calculation, which should be represented as 0.1 divided by 40.0 plus 0. কত ছিল জানো?
0.05
হ্যাঁ 0.05 divided by 2.50. That is how you do your calculation. এখানে কোনো স্কয়ার বা রুট প্লাস মাইনাসের জন্য তো স্কয়ার বা রুট আসে না। স্কয়ার বা রুট গুলি আসে হচ্ছে আমাদের মেজারেবল কোয়ান্টিটির গুলোর উপর যদি পাওয়ার থাকে, তাহলে সেই পাওয়ার গুলা মাল্টিপল হিসেবে সামনে আসে। Do you understand what I'm saying? If you are still confused, let me help you remember. এই যে personal uncertainty calculation process system হচ্ছে এটা, and then if we are having similar quantities, we just multiply it. If you have dissimilar quantities, we simply, I mean, let's say rho equals to m by volume, so m divided by pi r square l, so m divided by pi by 4 d square l এটা আসছিল। so m এর সাথে কোনো delta m by m একা বসছে, d এর উপর একটা স্কয়ার ছিল, twice into delta d by d হইছে। whatever the values that you get over here, their power gets as multiple of this fractional uncertainty. এখানে তো কোনো স্কয়ার বা রুট হয় না। have a look at the conversion. মনে পড়ছে? হ্যাঁ ঠিক আছে, সমস্যা নেই। so are we clear with this question, everyone? I hope so. Moving on, any other question from this page? These are all pretty elaborate MCQ. Elaborate বলতেছি এই জন্য I'm saying using the word elaborate because you would require significant amount of time to calculate all of these numbers. You would require significant amount of time to calculate all of these numbers, but you have to be able to do that. You might feel like that these are not worthy of 1 mark. Well, to be honest, they are, because if you know how to do your calculation, any of these MCQs that is given over here should not take you more than 1 minute, in my opinion. And you're gonna try to answer 40 MCQs in 75 minutes. Because your MCQ paper exam will happen, paper 1 will happen in 1 hour 15 minutes, that is 75 minutes. You have to answer a total of 40 MCQs. So in my opinion, these questions might appear to be quite elaborate, but you have to bear with it. Moving on to the next page, page number 11. Any questions from page number 11? I'm going to discuss number 15 for sure. But if you have anything else other than 15, you tell me about it. পোলাপান, আমি তোমাদের এখন শুধু ওয়ার্কশিট চেঁচাই মেচাই করে যাচ্ছি, আমি কিন্তু কিছুদিন পরে ক্লাস টেস্ট না শুরু করব। I am trying to take help from a certain website which is specialized for online class test taking. You'd have access to that exam, online exams at a certain time frame, and you'd have to appear for that exam within a given time frame, sort of like GRE or SAT tests. So it's important that you do participate and keep up with the class procedure. Other than that, if you start piling up your homeworks or your chapter worksheets, at one point you'll lose interest in physics. Like physics অনেক কঠিন স্যার, এত ওয়ার্কশিট দেয়, এত হোমওয়ার্ক করা যায় না, হ্যান তেন পারফেক্টলি অলরাইট, সমস্যা নাই। তোমরা ক্লাস ওয়ার্ক করার সময় 100 প্রবলেম না করতে তোমরা অর্ধেক করো, 1/3 করো, তাও হয়। যখন তোমাদের ক্লাস টেস্ট নিব তখন তুমি আরো বাকি কিছু করবা, যখন তুমি ফাইনালি মক দিতে যাবা তখন তুমি আরো বাকি কিছু করবা, সমস্যা নাই। বাট একদম করবো না, এইটা করলে আলটিমেটলি আমার সাথে ক্লাস করে লাভ নাই। You might as well quit and fetch help elsewhere. So I wanted to talk about number 15. So have a look at number 15. I have a reason to choose number 15 because this is a question which incorporates a new idea which you need to understand. Have a look at number 15. 15. Let me select 15. Control C. Okay, দেখো. A student uses a digital ammeter to measure a current. The reading of the ammeter is found to fluctuate between 1.98 ampere and 2.02 ampere. The manufacturer of the ammeter states that any reading has a systematic uncertainty of plus minus 1%. Which value of current should be quoted by the student? Pretty interesting question. Questionের কন্টেন্টটা বুঝছো কিনা দেখো। এক্সপেরিমেন্ট করে সে একটা সার্টেন কারেন্ট মেজার করতেছে, তার ম্যাক্সিমাম এবং মিনিমাম ভ্যালু অফ দ্য কারেন্ট, বিকজ ইট সেজ ইট ফ্লাকচুয়েটস বিটুইন দ্য ম্যাক্সিমাম কারেন্ট এন্ড দ্য মিনিমাম কারেন্ট এর ভ্যালুগুলো হচ্ছে 1.98 and 2.02. And the manufacturer also told us that there would be a 1% systematic uncertainty for the measure. 1% systematic uncertainty মানে হচ্ছে pretty much like 1% error that is provided from the device. এখানে ডিভাইসের এররটাকে সিস্টেমেটিক আনসার্টেনিটি বলা হইতেছে, বাট টু বি অনেস্ট systematic uncertainty should be always only plus or minus. So this is a bit of a self-contradicting word, that systematic uncertainty we should only shift the data to one direction. So systematic error can or cannot be plus minus. What the manufacturer is trying to mean is that whatever you are going to measure out of a device is not going to be exactly accurate. It might be 1% more or less. Here, by using the term systematic uncertainty, they are telling you the amount of error there might be because of the limitation of the device. So not to confuse that term. So how do we approach this problem? First thing first, what would be the average value of the current? 2.00. Beautiful. So I'm going to write this down. 2.00 is the average current. Okay? Now have a look. How much is 2.00 would have a random uncertainty? Have a look. এখানে আমাদের maximum value কত? 2.02, minimum value কত? 1.98. So আমাদের আমি তোমাদেরকে আগে শিখাইছিলাম, I taught you earlier that uncertainty of a certain value, or you can say uncertainty of a certain value can be also calculated if we know maximum and minimum of that value. That would come as maximum minus minimum divided by 2. I told you this procedure in this part of the note. When you go into the operator system, uncertainty of n equals to n max minus n min divided by 2. I explained it in this part. So if you forget about this, go back to the lecture on the YouTube channel and find this out. So I'm not going to explain why this works here, because this was discussed earlier. So you can find out the uncertainty from here. So how much do you get from here? 2.02 minus 1.98 divided by 2. What does that give you? আমি খাবো না, ঢাকে রাখো, আমি ক্লাস শেষ হলে 9:30 পরে খাবো।
0.02.
You get 0.02. Thank you. এখন কিছু খাবো না, লিখে একটু আগে বলবো। 0.02 ampere. So you are getting a random uncertainty of 0.02 ampere exclusively from the random uncertainty. এটা হচ্ছে আমাদের এররের একটা সোর্স। আরেকটা সোর্স হচ্ছে 1%. This 1%, you have to understand, this 1% of what? 1% of the original number. And 2.001 এর 1%, 00 ampere 1% কত? এটা 1% কত হয়?
0.02.
0.02 ampere. Plus minus obviously, because again plus minus বলা দেওয়া আছে. So this would mean that from the quality of the reading, we have a random uncertainty of 0.02 ampere. Because of the limitation of the equipment, we have a systematic uncertainty of 0.02 ampere. And like I have always been telling you, errors will always add up. Uncertainties will always get added up, because more errors can conflict bigger error. Error will not be taken to be compensating each other by default. So the total uncertainty of the value would be the addition of these two numbers. So how much do you get? 0.04 ampere plus minus. So the final answer হবে কি? 2.00 plus minus 0.04. Which is the correct response?
D.
D is the correct response. Calculation step দিলে বুঝা গেছে কিনা দেখো everyone.
Yes, sir.
Any question?
No, sir.
কই ছিলাম জানো? আচ্ছা, এখানে ছিলাম। এখানে আর এর চেয়ে বড় কিছু আমার বলার নাই। এই ক্যালকুলেশনগুলো তোমাদের কাছে অনেক কঠিন মনে হতে পারে, বাট দ্য অনলি থিং দ্যাট ইউ হ্যাভ টু আন্ডারস্ট্যান্ড দ্যাট আচ্ছা আমি এটা একটু আলাপ করি, নাম্বার 17টা একটু আলাপ করি। নাম্বার 17টা একটা ভালো কোশ্চেন, এটা ক্যালকুলেশন করতে হয় না, না করলেও পারা যায়। Have a look. The question says the Young modulus of material of a wire is to be found. The Young modulus E is given by the equation E equals to 4FL divided by pi d square x. এই ইকুয়েশনটা আলটিমেটলি তোমরা ইলাস্টিসিটি চ্যাপ্টারে শিখবা, যেহেতু আমরা এখন ইলাস্টিসিটি চ্যাপ্টার পড়ি নাই, so we didn't yet come across the elasticity chapter, so you don't know this equation, but ultimately this equation will be taught to you as part of your AS syllabus. For the time being, just believe the equation. The wire extends by a known force and the following measurements are made. Which measurement has the largest effect on the uncertainty of the value in the value of the calculated Young's modulus? Which one will affect the uncertainty of E? Which one will affect delta E the biggest? before I even look at this data, have a look at these variables. Let me take this question out. Have a look at these variables. What do you see? This is a constant, this is a constant. Constants are out of the question to add any uncertainty. Constants are constants. 4 is a constant, pi is also a constant. F is a single quantity, L is a single quantity, D has a square on it. Get this. And X has a single quantity. So if I just try to write the equation for fractional uncertainty, how is it going to look like? Delta E by E equals to কি আসবে? Delta F by F plus delta L by L plus twice delta D by D plus delta X by X. এরকম আসবে না?
জি স্যার।
So you can already see that because of the square, the fractional uncertainty of diameter is becoming double, whereas everyone has their own personal fractional uncertainty. So other than adding these up all together, like you have learned earlier, we are now trying to compare that among these 4 sources of uncertainty, which one will contribute biggest to this number. So let's calculate all of these numbers individually. So give me these fractions, everyone. Do some different calculation and tell me this number. Del F by F gives you how much? Give me. Up to 3-4 decimal places so that we can get a comparison.
It's 0.0009979.
Okay. এটা হচ্ছে এটা। ডেল্টা এল বাই এল কত আসে? আরেকজন এটা করো, আরেকজন এটা করো।
ফ্র্যাকশন বলবো নাকি ই বলবো?
না না না, ডেসিমেল বলবা। ডেসিমেল বললে কম্পেয়ার করতে ইজি হয়। Tausif, you'll tell me this one, and then Ankita, you'll tell me this one. এটা কত আসে ইফাত?
0.037.
0.037. আচ্ছা, তাওসিফ বলো এটা কত আসে? ডেল্টা ডি বাই 2 ডেল্টা ডি বাই ডি কত আসে?
না, ক্যালকুলেটরটা লাগবে। Sir, I am not having a calculator.
Shouldn't you have a calculator for your physics coaching?
স্যার
Yes, master, বলো।
ঝামেলা হয়েছে, ওটা ভুল বলছি আমি ওগুলা। ওরা লাইক ডেল্টা পার্সেন্ট ডেল্টা এল হয়ে গেছে, ডেল্টা এল ডেল্টা এফ বাই এফ আসলে ডেল্টা এল বাই এল।
মানে এটা হচ্ছে এটা, এটা হচ্ছে এটা।
জি স্যার।
আচ্ছা, সমস্যা নাই। So এটা হচ্ছে okay, other than doing that I can actually replace these two numbers. এটা এখানে যাবে। See, it's very easy to replace stuffs over here. So bam and bam. এটা okay.
ক্যালকুলেটরটা
Acha Tausif, you arrange your calculator. For the time being, I'll take the value from someone else. Anyone else? Give me this number. 2 into delta d by d. Altogether, 2 দিয়ে multiply করার পর কত আসে? Give me this one.
Sir, 0.0741.
And Ankita, what is the value for delta x by x? Hello? Ankita Nandi, are you here?
Yes, sir.
Can you give me this number?
I'm not sure.
Delta x by x, here is the value. This is the symbol for x. This is delta x.
Yes, sir.
This is the uncertainty. This is the value of the x. So you are just gonna do a ratio of these two numbers. The uncertainty goes on the numerator side. The value goes on the denominator. You get the fraction. Give me this number. I will help you.
Sir, help.
Sir,
এটা হচ্ছে ডেল্টা এক্স,
0.2.
এটা হচ্ছে হ্যাঁ এটা হচ্ছে এক্স। সো ইউ আর ট্রাইং টু ফাইন্ড আউট দিস দিস রেশিও। আই ওয়ান্ট ইউ টু টেল মি দিস নাম্বার আপ টু কাপল অফ decimal places.
Sir, 0.0384.
Beautiful. There you go. So now you can compare between among all the values, and you can see that logically this one is the biggest attributor towards the fractional uncertainty of over here. So that's the point that I was trying to make, that in most cases, other than doing the calculation, just by looking at the power, we can pretty much assume that which will attribute towards the uncertainty the biggest. The one that has a bigger power would always pretty much be the most attributing factor in most cases. But still, if you wonder, তাহলে আমি calculation কেন করলাম? Calculation করলাম এই জন্য just to make sure that I do score this 1 mark. It might have been possible that some of these values were so big that if any of these 3 numbers posed a value bigger than this one, I should have checked. I should have chosen that value. Just to be on the safe side, I did all the calculations individually, and pretty much my prediction turned out right, that the one that has a power of 2 pretty much went for the verdict. Someone said, "Sir."
না ওটা doesn't matter, but still আমার এই যে ডেল্টা এফ বাই এফ এর ভ্যালুটা একটু ডিফারেন্ট আসতেছে।
It's a different, ওটা মানে
কত আসবে বলো?
স্যার আমার আসছে 0.000509697, তাও smaller than delta d by
সমস্যা নাই, I could get my point across, right?
yes sir.
আচ্ছা, so I'll moving on from here. এটা গেল এই কোশ্চেন। এর পরের গুলাতে এখানে হাবিজাবি কোশ্চেন আছে, এটাও মোটামুটি সিম্পল ভ্যালু, এটা ট্রাই করলে তোমরা পারবা, প্রবলেম নাই। আচ্ছা, let's get into this part, graph and instrument reading. এই 1.4 হচ্ছে খুব ইম্পর্টেন্ট জিনিস। 1.4 কি কেউ তোমরা করছো বাসায়? Did any of you attempt this thing? Because if I start to discuss this thing without you attempting this would not make sense to most of you. I need you need to for yourself to attempt this problem first on your own to make sense of what is going to happen for the discussion of this part. Okay, no response, so I'll assume that's a no. তোমরা 1.4 টা বাসায় সবাই attempt করবা as much as you can. There are a lot of problems which are repeated, but I want all of you to try out this thing. And next class কবে? পরশুদিন না? হ্যাঁ, স্যাটারডে 7:30টায়। সো নেক্সট ক্লাসে আমরা এইখান থেকে শুরু করব ডেফিনেটলি। সো আই এম কিপিং দিস অ্যাজ এ কনফার্মড হোমওয়ার্ক, প্রায়োরিটি বেসড হোমওয়ার্ক ফর অল অফ ইউ। অ্যাটেম্প্ট, তোমরা ভুল করতে পারবা, ইউ আর অ্যালাউড টু ডু মিস্টেকস, কিডস বিলিভ মি অন দিস ওয়ান। The entire point of having classes is that you are allowed to do mistakes. Where you are not allowed to do mistakes is your final exam, board exam. Even in my class test, you are allowed to do mistakes as long as you learn from your mistakes. তুমি একই মিস্টেক সারা জীবন করে গেলা, তাহলে তো সেই মিস্টেক করার লাভ হলো না, তাহলে আমার কাছে পুরো লাভ হলো না, তুমি ডাম্বি থেকে গেলা। ভুল করবা একবার, দুইবার, তিনবার, বাট চতুর্থবার, পঞ্চমবার গিয়ে যাতে সেই ভুলটা না হয়। You need to learn from your mistakes and overcome your mistakes. That's the whole point. Is there any more part of this thing, or this is the last segment of this whole worksheet? Yeah, apparently this is the last segment of the whole worksheet. So I'm keeping this entire 1.4 as your homework. There are 28 MCQs, 31 MCQs over here. I might as well guess that about 8 to 9 MCQs are repeated. So anyway, I have incorporated the repeated MCQs over here as repeated, just to give you kids the idea that CIE actually, I mean, the CIE question paper actually do get repeated from the past year question papers. So why is that information important? To go ahead and show you that if you do put in a good amount of effort, you might as well get quite a lot of questions common from the previous years. Let alone that, for those of you who are still continuing with your schools will always, I'm not bragging or anything, because these are compilation of 10 years worth of question papers. A lot of your school questions will be common from these papers. So if you put some good effort here once, you'll be reaping the benefit in a lot of upcoming tests. But একটা point থেকে তোমাকে good effort put করতেই হবে. The earlier you put it, for longer period you're gonna reap the benefit. So the choice is yours. I'm gonna move on to the paper 2 question right now, so I can solve some questions from here. I believe we did solve some problem from this question, right?
Yes, sir, we did.
I remember very clearly that we talked about this. We talked about the graph plotting, which was this question, I believe. যে protector কিভাবে বসাইতে হবে and everything. How could we plot this one? Yes, we talked about this one, and then if I go ahead forward, we just talked about beautiful. Thank you, I love you. We just talked about the setup of this question. So এই question আমাদের কিছু question আছে. So kids, কমার question দাও, question বলা শুরু করো. Page number 7, question number 7 or 8. কার কোনো প্রবলেম আছে কিনা? Anyone?
Sir, when we calculate uncertainty, like আমরা like পুরো answer লিখতেছি না, যে like value plus uncertainty লিখতেছি না।
কথা কেটে গেছে বাবা, আবার একটু বলো, কথা কেটে গেছে।
Sir, so when we write the uncertainty value, just the uncertainty, not you know, this the value plus minus uncertainty, just the uncertainty, তখনও কি ওই fraction মানে decimal place-টা ই করতে হবে ভ্যালুর সাথে?
No. If you are writing the uncertainty on its own, you might as well write this up to 3SF or even more. But whenever you combine the value with this uncertainty and making a combined expression, then you have to sync them up.
Okay, sir.
How many of you could understand what she asked? I wouldn't say every one of you did understand what she asked. I can bet on that.
Sir, could you say that again?
I will say that again. Let me choose you a problem where this would make sense. Bye Korea me.
Number 9 এর ওখানে লাস্টের ছিল, number 9C তে ছিল।
এটা? না, number 9 না। পাইতেছি না তো কোথাও। আচ্ছা, আমি নরমাল একটা এক্সাম্পল দিয়ে বলি, যেহেতু এক্সাম্পল খুঁজে পাইতেছি না, পরে সামনে আসলে বলবো। এই যে পাইছি, বলতে পাইছি। ইয়েস, লাকি গাই I am, that is. So এখানে বলছে হচ্ছে measurements for a sample of metalware are shown in figure 1.1. We are given with some multiple measured quantities, and then we are asked to give some unit, state the appropriate instrument used to make each of these measurements. এটা তো আমাদের বোঝা লাগবে। Have a look. The value of length is 1750 millimeter. Now 1000 millimeter means what? 1 meter. So this thing was made there. So if you think in terms of millimeter, this was measured up to as about 175 centimeter or 1.75 meter. To make a measurement that is longer than a meter, a convenient measuring equipment should not be a meter rule. It should be a measuring tape. If you use a meter rule, you can measure a length longer than a meter rule, but then you have to do 2 repetition. So তোমাকে 1 meter measure করতে হবে, একটা দাগ দিতে হবে, এরপর মিটার রুলটাকে আবার উঠায় নিয়ে এসে you have to take out the meter rule once again from that previous marking, and then you have to align that mark with the 0 side, and then you have to take the second reading. Because you're repeating the process of observation, there are more random errors getting added. Because like I told you earlier, that every single observation that you have to make on your device adds up 1 plus minus 1 millimeter. Do you remember that do you guys remember?
Yes, sir.
What I'm meaning over here is that is that every observation that you make to make a measurement would incorporate one smallest fraction of that device as uncertainty. So in my opinion, a convenient device over here should be a measuring tape, because you can see over here as well that it says the uncertainty of the length is plus minus 3 millimeter. Now our typical meter rule, which is the typical meter rule that you have, a typical meter rule has a smallest fraction of 1 millimeter, not plus minus 3 millimeter. But here it says it is a fractional uncertainty of plus minus 3 millimeter, which in my opinion is also quite troublesome. Can you please tell me why? I mean, why these two numbers are not agreeing with each other? Can someone tell me that logic? Anyone?
No, sir.
Asha. Let me give you a simple idea. The uncertainty of a measuring device basically represents the smallest fraction it can measure. For example, at a meter rule, the uncertainty for a meter rule is plus minus 1 millimeter, because the smallest length that you can measure using a meter rule is 1 millimeter. The length between two of the closest lines in a meter rule is 1 millimeter. This essentially means every measurement that you make out of a meter rule will be a full multiple of that smallest fraction. Any length that you measure might be 1 millimeter. Any length that you measure might be 21 millimeter. Any length that you measure might be 634 millimeter. Using a meter rule, you should not be able to measure fractions of 1 millimeter. Do I agree? Do you agree with me? The meter rule is capable of give you readings which are full multiples of 1 millimeter, because that is your smallest measurement unit. For example, something like, let's say, তুমি যদি একটা শাড়ির length হাত দিয়ে measure করো যে 12 হাত শাড়ি, your হাত is the measurement unit. You cannot measure a fraction of হাত. একটা শাড়ি 12 হাত, নালে 13 হাত, নালে 11 হাত, নালে 2 হাত, নালে 14 হাত, something. So exactly like that, 1 millimeter is the smallest step size for a meter rule. Can I get my point? ঠিক আছে? So why am I telling you this? If have a look at these two data. Here it says the uncertainty is plus minus 3 millimeter. This would essentially mean every measured value that you get out of that device should be a full multiple of 3 millimeter. So you can measure 0 millimeter, 3 millimeter, 6 millimeter, 9 millimeter, 12 millimeter, 15 millimeter, 18 millimeter, goes on. That should be a full multiple of 3 millimeter, because your step size happens to be 3 millimeter. Is this reading 1750 perfectly divisible by 3?
No.
Check this out. 1750 divided by 3. Do you get an integer?
No, sir.
It means
sir.
what? It means that this number does not agree with this value. Now, this aspect that I'm telling you is not even a part of this question. I'm telling you this because this was brought to my attention by one of my students. Not even my eyes could grab this, and he or she asked me this question that, sir, this doesn't seem right. Why? Because of this, and I totally agreed with it. These are very, what can I say, God level observation, in my opinion. That they could see this number, and then the math worked in their head that this is not supposed to happen. And I totally agree with it. Do you kids understand?
Yes.
Yes, sir.
Now the
Why does it have to be a multiple?
Because you can measure that much every single step mark, with every single marking on your device. You have a mark at 0 millimeter, then you have the second mark you have at the 3 millimeter distance, then the third mark is at that distance.
But what if they took, like, since every time you measure in a meter rule, it adds 0.1 centimeters. What if they had to measure in 3 points, and that's why it added and became 3 millimeters?
That's my point. This device that they're talking about, that they use to measure the length, that has an uncertainty of 3 millimeter, which means that this device did not have marking of each millimeter. This device, this is let's try to visualize a special meter rule where the 2 millimeter mark and the 1 millimeter marks are erased. You have the 0 millimeter mark, then you have the 3 millimeter mark. then the 4th and the 5th millimeter marks are erased, and then you have the 6 millimeter mark. You have the markings on the measurement device every 3 millimeter apart. That's what it means.
Right.
বুঝা যাচ্ছে? Now, there is a logical explanation for why these values came like this. That answer can be
যদি অ্যাভারেজ করে
exactly. Ridwan, whatever you just said, that I was about to say that. So you just said that, let's say 1 second earlier. These numbers might as well be the average value of multiple of those readings. Because average is a numerical answer. Comes out of a mathematical process, which doesn't have to be full multiple of the raw value. The raw values should always be full multiple of the smallest fraction, whereas the average value can be anything. Kids, try to grasp this idea. একটা certain object কে তুমি length measure করতেছো, let's say ওই length measurement করার জন্য তোমার একবার 3.6 সেন্টিমিটার আসলো, একবার 3.7 সেন্টিমিটার আসলো, আর একবার 3.6 সেন্টিমিটার আসলো। তুমি তিনটা ভ্যালুকে যখন ম্যাথমেটিক্যালি অ্যাভারেজ করবা, you're going to get a fraction of 1 millimeter, which is perfectly good because mathematical average is a calculated number, whereas the raw values were 3.6, 3.6 and 3.7. The raw values of a measurement device can never be something else than full multiple of the uncertainty of that device, whereas the calculated value, namely average, can be anything. So a similar problem is available over here as well. Have a look. The uncertainty is represented as what? 0. What?
2.
0.2 ohm. So this should be a full multiple of 0.2 ohm if we assume this number to be a raw value. Since it is not, so we have to only decide one thing. These numbers that is shown over in this column, none of these numbers were single raw value. They were average value. After multiple measurements, they did the average and gave us this average value. That's the only decision that you can take. This discussion is not a part of this question, but I want you to appreciate the idea of numbers and how the measurement actually affect. Could I pass the idea across? বুঝা যাচ্ছে কি?
জি স্যার।
সাদিয়া, তুমি বুঝা নাই লিখছো, কোন পার্টটা বুঝা নাই? এখন কি ক্লিয়ার হয়েছে?
Yes, sir, এখন ক্লিয়ার হয়েছে।
শাবাশ। আচ্ছা শুনো, আমাদের ক্লাসের টাইম শেষ, 7:30 পর্যন্ত আমাদের ক্লাস ছিল। 7:30 পর্যন্ত ক্লাস ছিল না?
Yes, sir.
আচ্ছা, আমি এরপরে এই প্রবলেম আমি আবার নেক্সট ক্লাসে শুরু করব। স্যাটারডেতে তোমাদের প্রাইমারি হোমওয়ার্ক হচ্ছে 1.4 অ্যাটেম্প করবা। কিচ্ছু না পারলে কিছু করবা না, সমস্যা নাই। I want you to attempt all the questions. I'm not asking you to be geniuses. I want you to be industrious people. Okay? 1.4 পুরোটা অ্যাটেম্প করবা। আর যদি সময় পাও, যারা ওয়ার্কশিট একদমই টাচ করো নাই, কিছু ওয়ার্কশিট করা শুরু করো। If you feel like that আমি সব প্রবলেম করব না, ফাইন, do every other problem, do all the even number of problems. তুমি যদি মনে করো যে না আমি এতগুলো করতে পারবো না, 50% করতে পারবো না, do every third problem. 1 নাম্বার করবা, তারপর 4 নাম্বার করবা, তারপর 7 নাম্বার করবা, skip two each, but indulge in the process, get into the habit. বুঝতে পারতেছো কি বলতেছি?
জি স্যার।
Yes, sir.
সব করতে না পারলে কম করো, বাট একদম না করে বসে থাকো না, তাহলে খবর আছে, পরে গিয়ে এটা কুলাইতে পারবা না। ঠিক আছে? Are we cool?
Yes, sir.
Yes, sir.
Thank you very much. Thanks for your patience, and hope to see you in next class. Stay safe. Goodbye. The class is over.